In this video, we're going to continue our discussion with binomial probability distribution. So let's take a look at another example. Have you ever purchased an article of clothing, worn it once, and then returned the purchase? This is what is called a one-time fling. 10% of all adults deliberately do a one-time fling and feel no guilt about it. In a group of 12 adult friends, what is the probability of the following? Well, first off, let's write out to make sure all the conditions of a binomial experiment are here. I'm going to do that now. Okay, so the experiment is done 12 times, group of 12 adult friends. Trials are independent. That means the response of one person has no bearing on the response of another person. There's two mutually exclusive outcomes. Yes, you've done a one-time fling, or no, you haven't done a one-time fling. And the probability is always 10% of it happening, which is 0.10. The other thing I'm going to check very quickly, I'm going to do that n times p times 1 minus p is less than 10. Well, n is 12, probability is 0.1. 1 minus 1/10 is 9/10. And there, that's going to be 1.08, which is less than 10. So this does meet the requirements for a binomial experiment. Remember, when we put these in the calculator, it's x equal to x. That's a PDF. That's a binom PDF, n times p times x. Or it needs to be set up as x is less than or equal to x, which is a binom CDF of n, comma, p, comma, x. Let's take a look at the part A. No one has a fling. So for us, in this case, that's going to be x is 0. So we know it's n is equal to 12. P is 1/10, x is 0, so this is a binom PDF because it's x equal to 0, 12, comma, 1/10, comma, 0, and that ends up being approximately 0.2824. So I'm going to write the interpretation for this on the side now. So in 100 trials of this experiment, we would expect about 28 of those trials where no one has a one-time fling. Okay, let's take a look at part B. So at least 3 friends have done a one-time fling. So this is the probability of x is greater than or equal to 3. Well, that does not work because it's not less than or equal to. So I'd have to write its complement. That's 1 minus the probability of x is less than 3. But again, it's got to be less than or equal to. So I can rewrite that as 1 minus the probability of x is less than or equal to 2. Well, how would I put that in the calculator? That's 1 minus binom CDF, because it's less than or equal to. And again, the n is 12, the p is 0.1, and in this particular case, the x is going to be 2, because that's what makes it less than or equal to. Putting that in and rounding to 4 decimal places, you get that. Okay, let's take a look at part C. So no more than 5 friends have done a one-time fling. So that is the probability as x is less than or equal to 5. Well, that's good news for us. That means I can immediately put this in. So it's a binom CDF, and it's CDF because it's less than or equal to 12, 1/10. And again, for this particular part, that's going to be 5. Rounding that to 4 decimal places, I get this. Okay, let's take a look at part D. So greater than 2 friends. Well, I write that as the probability as x is greater than 2. The problem is I can't write that because it's greater than. So I write its complement. So that's 1 minus the probability as x is less than or equal to 2. Well, I can put that in the calculator. That's going to be 1 minus binom. Again, CDF, because it's less than or equal to 12, comma, 1/10. And again, this particular part, because it's greater than or equal to 2, is 2. Putting that in and rounding to 4 decimal places, I get this. Okay, let's take a look at part E. So this is going to be between 2 and 4 friends, inclusive, that have a one-time fling. So this is the probability of x equal to 2 plus the probability of x equal to 3 plus the probability of x equal to 4. So this is 3 separate binomial PDFs in this particular case. So let's write it out. So this will be binomial PDF. That'll be still 12, 1/10 here for 2, plus binomial PDF 12, 1/10, 3, plus binomial PDF 12, 1/10, 4. Adding those 3 together, you get this rounded to 4 decimal places. Okay, let's take a look at the mean and the standard deviation of a binomial random variable. So the mean is just going to be n times p. The standard deviation is going to be the square root of n times p times 1 minus p. So let's calculate the mean and the standard deviation from the previous example. Okay, so remember, n is 12. Right? We know p in this particular case was 10%, which is 1/10. And then the 1 minus p, that's 1 minus 1/10, that's 9/10. So let's write it out. So the mean is equal to n times p. N is 12, probability is 1/10. That's going to be 1 2/10 people. Don't forget to use your unit of measurement here. And now I'm going to write out an interpretation for this now. So we would expect in a random sample of 12 people, about 1 person would do a one-time fling. Okay, let's do the standard deviation. So again, square root, we know that's 12 times 1/10 times 9/10. That is going to equal 1 8/100. And rounding it to 1 decimal place, that's about 1.0.